Hey, welcome everyone. Welcome to our quadratic formula video. So, this is a video for the last week of April, and it's actually going to be only one video for this week as opposed to two because this is going to be a longer lesson. It's just an important one. We're going to have to go over a bunch of different examples, try a couple of things online for a calculator. Uh, yeah, we're just going to go ahead and do our best to get through the entire thing. And I'll give you a couple of points where you might want to pause and say, okay, you know what? I'm going to take a break here, for a little bit. And then afterwards, come back to it later. In addition, there's an optional part. Normally, if it was like a regular class, this would actually be like an optional thing that would be able to get you some extra credit. Unfortunately, I don't really know how to do the online extra credit, especially since I'm giving everybody 100%. But let's just say, if your grade's, an 88% at the end of this all and you do this guy, then maybe I'll look nicely upon you and move that grade up a little bit, or that kind of thing. Anyways, let's get going. Let's start on this, and good luck. Here we go. So this guy is called the quadratic formula. I know it might have been a bit since we remember these words, so let's go over a couple of the words here. The word quadratic, remember, this means right here that this is going to be anything of the form x squared plus dot dot dot. Anything that has an x squared in it going to be quadratic, unless there's also an x cubed, in which case it wouldn't. So x quadratic means that there is an x squared and the highest is x squared for that exponent. Yeah. So how do I quickly find solutions? Remember that the solutions is basically you're solving the equation. You're finding out what does x equals what. That's a solution right there. That's what this guy's talking about. And this is for complicated quadratic equations. So I'll give an example of that in just a bit. We'll do that. And I'll talk about it briefly at the very, very end. And that reminds me, I have one more example at the very, very end that I'll have to cover. So I'm going to have to add another example that I haven't even written down. Whew. All right. And then here we have the objective I like to write down. Again, that's an optional thing. But the objective that I'd have on the board is I can solve any quadratic equation. Remember, equal sign. By using the quadratic formula. Quadratic formula, I've written two different ways right here. You should write both of them down. However, when you start using them, you're going to have a choice as to which ones to use. The one that's written down here at the bottom is the one that most students end up remembering. However, I can tell you that this one up here is occasionally easier to use, so you kind of just need to pick and choose which one is the best. However, most students end up memorizing this one because it's only one fraction as opposed to two different ones. In my experience, when students are using the calculator, they tend to make fewer mistakes when they use this one up here as opposed to the one down here, but we'll see what happens. Derivation is what this word says. Derivation. Derivation. And I said it's optional. And the reason why is I'm going to show you where in the world all that craziness comes from. Where the b squared minus 4ac, where this divided by 2a, where all of this nonsense comes from. We're going to talk about it. And in case you needed me to say what these letters are, this is negative b divided by 2a plus or minus. That's a square root symbol, b squared minus 4ac divided by 2a. And these say the same thing, it's just one fraction. So let's go over this derivation. So if you don't want to write down or watch this next part, that's up to you. You can go right into the practice problems where we actually use the formula. But if you care about where this formula comes from, or you want to get that extra credit, or maybe you're just that bored, or you just love listening to my voice, you can hear me talk about this derivation here. So the goal in all these questions is to solve for x. And we've done factoring before. We've done completing the square. This is going to be a way just to jump directly to the answer. That is what this formula is all about, getting right to the answer. And to get to that formula, though, it takes a little bit of work. So, yeah, if you want to go through this derivation, here we go. So step one in derivation is to go ahead and take that c and move it to the other side of the equation. So we subtracted c on both sides of the equation. So as part of extra credit, if you really do want the extra credit, you want to make it look nice for yourself. You want these notes for later. You could actually write a little explanation over here on the right as to what you're doing every step. So you could say, hey, I moved C to the other side. I'm not going to write that down. However, if you would like to, feel free. Continuing on. So after that, what we're doing here is completing the square. So we move the c to the other side as part of our completing the square. And then now, in addition for completing the square, you had to have a 1 in front of this x squared. And if it's not a 1, you have to divide everything by that a. So that's what we're going to do. We're going to divide by a, divide by a, divide by a. If we divide this one by a, the a's cancel, and I just get x squared. This one, I could write bx over a, but it's actually better to write it as b over ax, like this. We'll see why in just a second. Those are a's, by the way. Those aren't 9s. Those are like the letter a. I apologize. Bad handwriting there. And now we are finally able to do our complete the square step with this nasty fraction. So our completing the square step, as a reminder, what we do is we write down that middle term. We write that b over ax. We take away the x. We divide by 2. Dividing by 2 is multiplying by a half. It's just putting an extra 2 on the bottom. So we're going to write b over 2a and put a star on it. By the way, that's where that b over 2a comes from in that formula from that previous lesson with the axis of symmetry. So you got b over 2a, and then we're going to square the entire thing as normal. b squared over 4a squared. So I squared everything. And that's the guy that we're going to add to both sides of the equation. Whew, too much writing to do, honestly. All right, so on the left-hand side, we are going to rewrite this as x plus, and it's always what we start over here, b over 2a, quantity squared, equals. And then here, this is where students honestly usually get lost, is you actually have to add the fractions. You have to make these to have the same denominator. So to make these have the same denominator, you need to take that negative c over a plus b squared over 4a squared, and you have to add those fractions. So I'm going to do that up here because I'm kind of running out of room. So I'm going to go up here and do it right here. So I got negative c over a plus b squared all over 4a squared. Now, first of all, in the formula above, if you noticed, it was b squared first. So we're actually going to write that b squared in front before we start this. Now, we need to have this needs to be a 4a squared and this needs to be a 4a squared. If they're both the same thing, we're good to go. So we're going to multiply this one by 4a over 4a, kind of like you would for fractions. You multiply the top and bottom by like 2 over 2 or 3 over 3 or something. We're going to do the same thing. So you have b squared over 4a squared minus 4ac divided by 4a squared. And now they have the same denominator, so I can rewrite it, b squared minus 4ac all over 4a squared. And that's what's going to go right here on this side. Whew! Okay, so what did we have written down overall? Let's just double check everything. So what have we actually done? We're completing the square, so we moved that c to the other side. That was easy. Divided everything by a. That was easy. But after that, not so easy. We had to take that b over ax, complete the square on it. So we took the x away. We divided by 2, starred it, squared everything. We took that squared thing and added it to both sides of the equation. Rewrote the left-hand side using the perfect square and the star. And on the right-hand side, we did some nasty old stuff of adding fractions, and we ended up with this guy. To solve the equation, you got to remember we are taking the square root of both sides, and we are supposed to write two different equations. But we're not going to bother writing both of those equations right now. We're just going to write the plus or minus sign. That's actually the most common step that teachers do. They use the plus or minus sign way earlier in the year. I don't like to. I like doing the two separate equations because it reminds people there are two answers. But here we're not going to do that. We're going to write plus or minus the square roots of b squared minus 4ac all divided by 4a squared. And I'm totally out of room, so I'm going to pause for a second, let you guys do it. If you need to pause and write it, you can, but I'm going to copy that onto the next page. So copying this guy onto this page here, we are finally at x plus b over 2a equals, and we have plus or minus, because that's a plus and a minus. There's two equations there, one that's plus, one that's minus. Big square root symbol, and b squared minus 4ac here, divided by 4a squared there. We need to continue to simplify this. We want to get x by itself. So to continue to simplify, remember a rule. If we have a square root of a whole big fraction, we have a square root on the top and bottom separate. Oop. Got ahead of myself. I started doing the next step. Okay, so we made the square root and the top and bottom separately. That top part is actually part of the formula, so we can't do anything with that, but that bottom part, we can rewrite that guy. So that guy is the square root. The square root of 4 is 2, and the square root of a squared is a. And we're actually finally almost done. We have one more step. We have x equals negative. We're going to take that plus b over 2a and move it to the other side. And there we go. That's actually the formula that we had written down on the previous page there. It's a minus sign in front of this guy, by the way. And again, we could write it as a single fraction if we'd like to. Not a requirement to write it as a single fraction, but you definitely are allowed to. Just like so. Anyways, that's where that formula comes from. We are done with the optional part. So, end optional. I don't know if I should write that down, but we need to get onto the examples and actually start using this formula for these questions. So let's go ahead and do that. So we're going to go right on to examples of solving for x. Here we go. So number 1, solve for x. So when you do this, we do it just like we were doing for the graphing part. We write down what is a, what is b, what is c. And we're going to start down writing a equals 1, b equals 5, c equals 6. So we have all three of these guys written down, a, b, and c, and we plug it directly into that formula. So for this part of the problem, it's actually nice and easy for the very first couple of times you do it to start doing different colors. So I apologize for doing this an extra time, but we're going to go through and do some extra colors here. We're going to do a equals 1. We're going to do b equals 5, and one more color, c equals 6, and I'm going to rewrite my quadratic formula using these colors so that we can see where each and every guy goes right away. I had said earlier that I like using the one that has two separate fractions, but we don't have to. We can use the one that only has one fraction. It's totally up to you. Let's just use the one that has one fraction because that's what most students end up using. Anyways, so it needs to be negative. And then we're going to use this guy for the letter B, plus or minus the square root, again, that B, and that B needs to be squared, minus 4. and then A, purple for C, and all divided by, maybe the light needs to be on for this part. I don't know, maybe I should have picked different colors. I don't know. Over 2A. All right, so we have all these colors. Basically, colors just need to be replaced. So pink's going to go into pink, blue's going to go into blue, purple's going to purple. And if we plug all those guys in, we are going to be good to go. So x is going to be equal to negative. And if you put parentheses around it, sometimes it helps to remind you what's going on. So you don't need to, but you can. I'm not going to on this one. So we got -5 plus or minus the square roots of 5 squared minus 4. And this is where the parentheses really do come into play because the written numbers are right next to each other. So we got 4 times 1. And then the purple guy is 6. My square root was not long enough. All divided by 2 multiplied by 1. Whew! All right, so we finally plugged everything in, and now for the rest of this is really just a matter of how are you going to use the calculator, what parts are you going to do without the calculator and just do by hand, what calculator are you even using. It's totally up to the person who's doing it. This is where I really, really wish I was in my classroom so I could hand out the calculators and we could practice doing this. Because I actually have a whole lesson where we learn some programming and we program the calculator to do these problems for us. Unfortunately, we don't have calculators right now, and we're going to have to hold off on that programming until, I don't know, maybe when you have me in 11th grade or something. Kind of a bummer. Really wish I could show you that programming stuff, but I can't because we don't have the calculators. It's sad. We're just going to have to go ahead. I'm going to show it this time with no calculator whatsoever because you don't necessarily need one for these problems. It's just really, really helpful. So let's just do it. So we have x equals, and we're going to do -5. We're going to keep that plus or minus. And we're just going to do our PEMDAS rules. So our PEMDAS rules say we have to deal with these exponents first. There's that 25 minus, and you have to multiply before you subtract. 4 times 1 is 4. And 4 times 6 is 24. Excuse me. And 2 times 1 is 2. I'm totally running out of room, and I've already written this next one down. Probably shouldn't have done that, so I'm kind of going to do bad math and go this way. I'm going up here. I apologize for that, but that kind of needs to happen. So we have x equals -5 plus or minus. Now a square root symbol acts like a parentheses. Because of that, we have to go ahead and subtract there first. So square root of 25 minus 24 is 1. Divided by 2 times 1. X equals -5. The square root of 1 is 1, so plus or minus 1 divided by 2. We are so close to being done. Now, just like before, where we had 2 separate answers for these questions, we again have 2 separate answers, and this is the part where we actually need to start writing that. So we're going to split this into 2 parts. I'm running out of room, so I'm going to do it like this. We have x equals -5 plus 1 divided by 2, and x equals -5 minus 1 divided by 2. -5 plus 1 is -4 divided by 2. -5 minus 1 is -6 divided by 2. Finally, my answers are x equals -2 for this guy and -3 for this guy. Now, we did all of that work. Technically, you don't ever have to factor again if you don't want to, because you could always do this. But let's go back to the original question. How much easier would it have been just to say, oh yeah, I remember how to factor this. What multiplies to 6? 1 times 6, 2 times 3. Which one of those adds up to 5? Oh yeah, 2 times 3 there. We got 2 plus 3 is 5. So I could easily rewrite this as x plus 2 times x plus 3 equals 0. Use my quick zero product property there. The zero product property says x plus 2 equals 0, and therefore x equals negative 2, and x plus 3 equals 0, and x equals negative 3. Oh my gosh, that was so much easier than doing all of this. So, Mr. Richards, why are you wasting our time using quadratic formula? Well, problem number 2 here. That ain't going to work. Quadratic formula is not going to help us out. The factoring is not going to help us out. Nothing is going to multiply to 3. We got this negative in front. All that stuff's going to be no fun. So, yeah, we're going to have to do this one all the way around. So, let's do it all the way through. So, by the way, if you have been watching since the whole derivation thing and you did that little extra credit thing, you probably want to take a break because you've been watching for 20 minutes now, and that might be the point where you need to, just chill for a second. I don't know. Anyways, let's continue on. We have A equals negative 1. We have B equals 7. And we have C equals 3. And we're just going to plug it directly into that formula right away. So here we go. We have x equals, and we have negative b plus or minus the square root of b squared minus 4ac all divided by 2a. All right, well, here we go. We got a lot of stuff to do. I said earlier that we could do this with a calculator. This is not one where I'd really need a calculator yet. None of these numbers are too awful and terrible. So we're just going to do it with no calculator here. Let's continue on. X equals negative 7 plus or minus the square roots. 7 squared, 7 times 7 is 49. And this guy is 4 times negative 1 is negative 4. Negative 4 times 3 is negative 12. Minus negative 12 is plus 12. All divided by negative 2. Then we're going to go ahead and say x equals negative 7 plus or minus the square roots. 49 plus 12 is 61 divided by negative 2. Oh, camera's not covering it all. And this is the part where, again, we want to go into two answers. Square root of 61 doesn't actually have a square root, so we can't do anything with it. We're just going to write x equals negative 7 plus the square root of 61 all divided by 2. And x equals negative 7 minus, actually, I just drew the extra arrow. We're going to do it down here. X equals negative 7 minus the square root of 61 divided by 2. And there we go. We've gone through two examples. I am actually personally going to take a break. Just a moment, pause the video. Alrighty, guys. I am back. So you weren't, for you, I wasn't gone at all, right? So it was just me being gone out in the ether. So here we go. Continuing on with these questions. I want to, before we continue here, we've seen two problems so far. One that was easier to solve by factoring and one that couldn't be solved by factoring. And how do you tell the difference between the two is honestly, there's not really an easy way to do that. We're going to do a little bit of a video next time on that. But for now, we're just going to be solving everything with the quadratic formula. So if you want to, you are allowed to start trying on your own once I say so in this problem, because there is one step you need to take before you would try it on your own here. And the reason for that is quite simple. In this question, if you notice, things are not set up in the form that we are used to. We are not set up yet in the ax squared plus bx plus c equals 0 form. And if we aren't set up in that way, we don't really know what a is, what b is, what c is. So we got to do that. So first of all, we're going to take that 2x squared here. We're going to write that first. We are rearranging. And then we're going to take that 7x. That's going to come second. And that negative 3 is on the wrong side, so it needs to move to the other side of the equation. When you move it to the other side of the equation, it is now going to be a plus 3 equals 0. All right, so let's continue on. Let's do this. We need to write down what A, B, and C are. So we have A is equal to 2, B is equal to 7, and C is equal to 3. And we just got to start plugging it in. So we have x equals. So you don't have to write x equals in front of everything if you don't really want to. This is like, I'm just going to write x equals ... for everything, because I know that's what I have to do at the end. If you're comfortable doing that, do it. Otherwise, write x equals in front of every step. And we have negative b plus or minus the square roots of b squared minus 4 times a times c, all divided by 2 times a. And we just have to continue simplifying. So we have negative 7 plus or minus the square root. 7 squared is 49. Minus 4 times 2. 4 times 2 is 8. 8 times 3 is 24. So minus 24 divided by 4. 2 times 2 is 4. Running out of room again, so I'm going up here. I really should not have written these problems down in advance, but that's what I did. Negative 7 plus or minus the square root of 49 minus 24. So 49 minus 24 is 25 divided by 4. Square root of 25 is 5. I forgot to say you could pause and do it on your own. I feel so silly. You could have paused and done it on your own earlier once we had rearranged it. I'll give you another chance in a question in just a minute. I apologize. So the square root of 25 is 5 divided by 4. And now we have two separate problems here. Negative 7 plus 5 is negative 2 divided by 4. Negative 7 minus 5. So this is the negative 7 plus 5 divided by 4, sorry. This is going to be the negative 7 minus 5 divided by 4. That's going to be negative 12 divided by 4. And finally, we can actually rewrite our answers by simplifying. Negative 2 over 4 simplifies to negative 1/2, because you divide the top and bottom by 2. Negative 12 divided by 4 is negative 3. Now, I did promise that we could do this stuff all in an online calculator. It is very good practice to do all of this work, and the reason why is quite simple. It makes you practice all of your orders of operations. It makes you practice, multiplying, dividing, all that kind of stuff. That's just good for keeping your math up, especially given the fact that you've not done that much math in the past month. So I do recommend actually trying every problem this way, but if you really just don't want to, when you have the homework, which isn't going to be assigned till next week on this, you can use Wolfram Alpha. So let's go ahead and use Wolfram Alpha. I'm going to pause the video really quick so I can get it all up. All right, so we are no longer paused. We are back to Wolfram Alpha. So unfortunately, if you're watching this on like a phone or an iPad or something, you don't have a separate computer, it's hard to, I understand, someone was telling me about this in tutoring the other day, it's hard to do this video, go back and forth between the two. So I really wish I had a better way of talking about it, but I just don't. But I'm going to give you a few different ways to do this. Because you still want to be able to show your work. I still want you to understand doing this stuff, but stuff like Wolfram Alpha can actually do all of the work for you. And if if you had been in my class, like I said, I would have helped you program your calculator to do this work for you. So you would have had the calculator option to just go, okay, boom, I did all of the work in the calculator, and you didn't have to do any of this stuff by hand. So how much you do by hand is totally up to you. And if you ever did have to use this stuff, later in a physics class or something like it, you'd most likely have a calculator at your disposal. So I don't know how much. I'll have to actually ask Mr. Blevins one-on-one what he would let you do. But for now, we have Wolfram Alpha. We're going to go ahead and have Wolfram Alpha do a bunch of the work for us. So Wolfram Alpha is super powerful. You could literally type in the word solve, and it will give you the correct answer. So we're going to type in solve, parentheses, and we're inside of this parentheses, we're going to go ahead and type in the original problem. 7x plus 2x squared equals -3. Oh, and I apologize about the loud keyboard. I actually was going to buy a new one that has not so loud keys, but they're on back order due to the coronavirus until June. So I guess I'm not going to order one, save myself some money. You don't actually have to type this comma x at the end, but if you do, it kind of works a little bit faster because Wolfram Alpha knows what to do. Anyways, it tells us the correct answers that we had in our paper, -3 and -1/2. So does that work for us? But maybe we didn't want to do all of that. We didn't want to totally cheat. We only wanted to use a part of it. So let's say we got to the part where we'd actually written down all the numbers. So negative, I'm going to type it in, and it's going to give us the wrong answer, and we're going to talk about why it gives us the wrong answer in just a moment. So plus, minus, like this. I don't know what it's going to, I actually don't know what it's going to do when I type it in this way. Square root is SQRT. That will give you a square root symbol. Parentheses, 7 squared minus 4 time, we did parentheses, 4 times 2 times 3, end of parentheses, divided by 2 times 2, and we hit enter on this, it gives us -12. And look at what it did. It did this. The deal is we have a lot of parentheses problems with what we typed in. We need to be super duper careful, and this is actually true when we use the regular calculator, and you also can't do plus or minus. Wolfram Alpha and actually the calculator that you use at school does not understand plus or minus. She'll actually have to do 2 separate problems, one that's plus, one that's minus. So we're going to go back, we're going to delete that plus sign. We're going to put some parentheses here. We need parentheses around the entire numerator. There we go. And then we also need parentheses around the entire denominator. So finally, it gives us the correct answer of -1/2 now when we do it. If we hit enter, it will actually give you the fraction version instead of just the decimal. Beautiful. And then now plugging it in some more. We also wanted the minus sign, so we're going to take that one that was a plus and change it to a minus. And sure enough, we get that -3 answer. Holy moly, was that a lot of work. So you could see it's a lot of effort if you do it this way or that way. And if we had just been able to use my version where we program it ourselves, when you program it yourself, it'll do boom, boom, boom. It'll just give you the answer immediately, even faster than typing it in solve here. Anyways, we're going to transition back. We're going to go back to that Wolfram Alpha in just a moment towards the end of the lesson, because when you have the physics problems or the real world problems or the real reason we're even learning all this stuff, you're going to want decimal answers. So let's go and do it. So 6 plus 2x equals -7x squared. Let's go. So we're going to add that 7x squared. We're going to move it to the other side here because, again, we need to be in the correct order of ax squared plus bx plus c equals 0. Also, by the way, we are officially at 33 minutes into this video, so if you have not taken a break, you really should. I mean, if we had been in a regular classroom, you would have been doing whiteboard problems and moving around the room and doing other stuff. If you're just sitting there in your room writing the stuff down, you're gonna drive yourself nuts and you're gonna get bored too fast or whatever. And again, like I said, this is 2 lessons in one, so maybe pause, take a break, just chill for a minute. Yeah. All right, continuing on. -7x squared, move to the other side. We have to write it in the correct order, so we want 2x on this plus 2x plus 6 equals 0. So again, what did I do? That -7 moved to the left, it became a positive. We wanted to write it in the correct order, so wrote the 2x next, and that is a positive 6. There's an invisible plus sign if you want to. Good to go. A equals 7. B equals 2. C equals 6. Right. That's a really bad 7, by the way. All right. So we have negative b plus or minus the square roots of b squared minus 4ac all divided by 2a. Okay, let's go. Continuing on, we have negative 2 plus or minus the square root. 2 squared is 4. 4 times 7 is 28. 28 times 6, you probably really want a calculator at this point in time. What are you going to get when you get 28 times 6? That's going to be 30 times 6, which is 180, and then you subtract 12. Yeah, then you subtract 12, so you get 168. Divided by 14, and then you get negative 2 plus or minus the square root of negative 164 divided by 14. And if you type that into your calculator there, that negative 164, it is going to tell you no real solution. If you type it into Wolfram Alpha, they do something fancy with the letter I. You know, and write an I answer. We're not going to do that right now. We're just going to say, oh, we have a negative under the square root. What does this mean? It means x equals NRS, no real solution. Remember, you can also write 0 with a little slash through it. You can write the cute little curly brace. That means no answer. You could write out the words no real solution. But the point is, we're actually done with the problem early because we have a negative in the square root. Negative square root, we're done. No more work can be done. Moving on to the next page. Problem number 5. All right, so problem number 5 here. So this one I wrote down on purpose as a kind of trick question because it looks like a quadratic formula problem and then something happens. Because we need this 2x squared to be moved to the other side, so we do that. So we have 2x squared, and we're going to take this guy right there, move it to the other side. It becomes minus 2x squared. Take that negative 2x, and it becomes plus 2x. Take that plus 4, take that negative 6, move it to the left, it becomes plus 6 equals 0. And then 2x squared minus 2x squared, that cancels out and it's gone. You get 0x squared. So you don't have to write it. Now, if you tried to solve this using our formula we just been doing, a would be 0 because it's 2 minus 2. B would be 2, and c would be 10. And you do negative b plus or minus the square root, blah, blah. We do all this stuff, but on the bottom, we'd have 2 times 0. So you divide by 0. You can't divide by 0. So you can't do any of this stuff. How do I solve that equation? That's what we've been did a million years ago. We learned this all the way back in October. Take that 10, move it to the other side. You get 2x equals negative 10. Get the x by itself, all these inverse operations. How do you get rid of that 2x? We divide both sides by 2, and then x is negative 5. So it's actually a trick problem. This one was not quadratic formula. It's just to point out if a was 0, you can't use a quadratic formula. We go back to what we did way before. All right, number 6. This one's special for a reason. Let's get to it and let's do the problem. And actually, I'm going to change this to a negative 6. So let's make that a negative 6 instead. So for this question, we're going to want to go ahead and start writing them down. A equals 1, B equals negative 6, C equals 9. And now we have negative B, so we have negative 6. It's going to be positive 6 in a bit. You can write positive right away if you want to, but plus or minus the square root of b squared, negative 6 squared. If you write it like this, you're going to get it wrong. You need to put parentheses around the negative 6. What do I mean by you're going to get it wrong? You're going to forget you're doing negative 6 times negative 6. This is what you need to do. You need to do this. You need to not do this. This is good. This, no good. Because this one up here is 36, and this one over here is negative 36. That is not what we want. We want the positive answer, because that's what we're doing. We're doing the whole thing squared. That's why I changed that to a negative, to remind ourselves to do that. Minus 4 times 1 times 9, all divided by 2 times 1. So let's do all this work. Negative of negative 6 is positive 6, plus or minus. Negative 6 squared is 36, minus 4 times 1 times 9 is 36, divided by 2. So now we have 6 plus or minus the square root of 0, divided by 2. The square root of 0 is 0. So that's 6 plus or minus 0 divided by 2. And this creates two different answers. We got 6 plus 0 divided by 2, and 6 minus 0 divided by 2. Well, that's 6 divided by 2, and that's 6 divided by 2. Either way, we get 3. We have x equals 3. We only have one solution to this problem. This is called a double solution, or a double root. It does happen on these questions on occasion. Because the answer showed up twice, so if you want to, you can write down a double root if you want to. Please note this is not going to be too important until your Algebra 2 time, but, you know, whatever. It's a nifty little idea. It just means you have the answer is twice. So if you want to, you could rewrite that as it means same answer twice. Sometimes when students have this lesson, they ask, well, are there triple roots? Are there quadruple roots? And the answer is yes, there are. But again, we don't have to worry about that until you take this in a later semester here. Let's continue moving. And again, if you have not taken a break, you really have to. We're at 41 minutes into this video. This is a long video here. It says there's only one more problem, but it's actually not true. We need another problem after this one. We need a problem number 8. Because, you know, sometimes we actually have to do real world problems. That's the point of math in the first place for a lot of people. Even though not for me, but for a lot of people. Okay, so in this question, there is no x. Because there is no x, we need to remember that anytime there's not a number in front, we just write 0. So b equals 0, and then c equals negative 16. So we have negative b plus or minus the square roots of b squared minus 4ac all divided by 2a. So that's going to give us negative 0 is nothing, so I don't even need to write it anymore, but we can. We don't need to. So you have plus or minus the square root. 0 squared is 0 minus negative 4 times negative 16 is negative 64 divided by 2. And plus or minus these square roots. 0 minus negative 64 is positive 64 divided by 2. And the square root of 64 is, of course, 8 divided by 2, which gives us our two different answers. 8 divided by 2 and negative 8 divided by 2, which is 4 or negative 4. So x equals 4 or negative 4. I'm going to go back one more time and try to convince you that factoring and what we learned earlier in the year is easier. Because if we go back to this is a special one. This is our difference of two squares. If you remember from earlier in the year, our difference of two squares ideas, if I had a squared minus b squared, I'll have a minus b times a plus b. And then after that, this guy is now going to become a minus 4 times, a minus b times a plus b equals 0. So I have x equals 4 and x equals negative 4. I just got a text from Miss Lisa Smith, so I'm going to pause the video and... So, text was actually a good one. They are doing construction work at our school because it's closed right now, so there's time to do it. And I'm going to get a brand new classroom next year, and they want me to go move my stuff. So I guess I have to go back to the school and move all my junk. Anyways, so finishing this problem, we have x minus 4, x plus 4, and x is 4, and negative 4. It is so much faster to do this compared to all of this stuff. This was so much work. This, so much better. Or even easier than that, remember, there's still the original way, the very first way that we ever learned how to do this stuff, I'm just going to go one more. I'm going to show you there's so many different ways you can solve problems. You don't have to do it one way. You have negative 16, add a 16 to the other side. What do you do when you have problems like this? Oh yeah, we split it into 2 and we do the square root. We have x equals the square root of 16 and x equals the negative square root of 16. We got x equal 4 and x equal negative 4. A bazillion different ways to do this question. You pick your favorite. Now, originally, I was planning on ending the lesson there, but I really want to do one more for the sake of physics teachers everywhere. I want to remind people the whole point of doing any of this stuff. So I'm going to scoot back just a little bit here and remind yourself, if you throw a pen up in the air, it follows what is called a parabolic arc or a parabola arc, or in other words, it's a quadratic. So if I had something like, let's say, me, and I had I was standing, I don't know, let's say I'm standing on the second floor of Gateway, second floor of Gateway, so I am maybe 20 feet up on the building. So I'm in the second floor of the building, I'm 20 feet above the ground. Or third floor of the building, maybe on the ceiling. I don't know. I'm 20 feet above the ground. And I throw my pencil up in the air. If I throw my pencil up in the air, it's likely I didn't throw it too fast. Let's say I threw it moving at a speed of, let's say 2 feet per second. So this is me standing up on a building up here where I am 20 feet above the ground. And I throw my pencil or a ball, and I throw it 2 feet per second up in the air. And if I throw this exactly straight up and down, 2 feet above the air, maybe I'm like underhanding it, like straight up. You can't even see what I'm doing. I'm crazy. If I do this, you can use the quadratic equation to figure out how long it's going to take for the pencil or the ball or whatever it is to hit the ground. So how long? It turns out, if you solve the equation, 0 for the height equals negative 16 times the time, that's a t, squared. Explain that negative 16 in a second. Plus 2 times the time, plus 20. 2 comes from there and 20 comes from there. Negative 16 is actually gravity. It turns out gravity, G, is negative 32 feet per second squared. That is gravity, and you have to divide by 2 for reasons I cannot prove to you right now. If your physics teacher wants you to do it, you can, or your calculus teacher later in life. I can explain it using calculus, but that's like literally 5 years away, so don't worry about it right now. Point is, if you divide by 2, you get this equation. And if I solve this equation, I will figure out when it hits the ground. So this is going to be our t equals, we got negative b plus or minus, all this stuff. So we have negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times 2. And because this is a real world problem where I want a real world answer, I really just want to use my calculator. So I'm not going to show you because I don't want you to have to write down too much stuff. But if I plug it into my calculator, what am I going to get? I'm going to get negative 16. I'm typing in the solve because I'm doing full cheat mode right now. Plus 2x plus 20 equals 0, comma x. You get 2 answers. We have, so if you do all this work, you end up getting t equals, why does it say that? If you simplify it and do all, why did I write 2 down here? A is negative 16. That was a mistake by me. I'm so used to writing the 2 in there. That's supposed to be a negative 16. You end up getting this guy. You end up getting negative 2 plus or minus the square root of 1,284 divided by -32. What an awful answer, right? And if you do the work on it, you get in calculator it and get decimals. You get t equals -1.0573 and t equals positive 1.1823. This is a real world problem. So we have these two answers. Let's look at the drawing that I did up here. So I threw it up in the air, and that's my parabola. Where it hits the ground right here, looking like a regular old parabola picture, these are our solutions where it equals 0. In this problem, this part of the graph doesn't exist. There's me on the building throwing it off over here. So this answer, this negative one, is nonsense. It doesn't matter in the real world. Only this one does, so my pen would only be in the air for about 1.1 seconds. That's about right. That's how long it takes for something to hit the ground off the second floor. Anyways, I bet you guys are done. This was a 50-minute long video. We will have practice problems and more of all of this lesson for next week. I apologize for that super duper long video, but again, this is the only one you have to do this week. Have a good one and enjoy the rest of your week.